Good morning, geometry students. I hope everybody's doing well. It's been a while since we've seen each other. When you guys last left off with the long-term substitute, Mrs. Bono, you guys took a test, and then we were going to start something new, but then school's been done for a while. And so what we're going to do is we're actually going to start Chapter 3. And so the point of my video today is just to go through the beginning of Chapter 3, and what I would strongly recommend that you do is you take out a sheet of paper and you can work on some of the work that I'm doing right now. It's not going to be required that you do what I'm doing in this video, but it's going to lend itself useful to be able to help you understand what's going to take place. To begin with, what we're going to do is we're going to talk about this new chapter, and this new chapter is Chapter 3, so we're in Section 3.1.1. Today what we're going to do is we're going to talk about this term called dilation. And dilation is just a fancy word for stretching or shrinking an object. So we've worked with transformations in the past, and transformations that enlarge a figure while maintaining its shape is called a dilation. And so we're actually doing this pretty much every day right now as we are working with Zoom or Google Meets or FaceTime or something. We see pictures of people who are much smaller on the screen than they are in real life, and that's actually a dilation or a shrinking or enlarging of something that is in real life. And so today we're going to talk about mathematically how we come up with that. And so what I reference is I'm going to go to problem 3.2 or 3-2 rather. And what we're going to do is we're going to work on what it means to actually dilate a figure. And so the problem here says when a figure is dilated from a point, the result is a similar figure. And so what do similar figures have in common? That's what we're going to answer here in these next couple of problems. So if you have your notebook out, what I would recommend that you do is maybe on your graph paper, draw this shape, A, B, C, D, at its specific points here. This point A is at the point 3, 2, so you can put that on your graph paper. B right here is at the point -1, -1, 2. Point C down here is at the point -2, 2, and D is at the point 1, -2. So if you have your notebook, now would be a good time to bust that out and draw this, and you could title your work Dilations, as that's kind of the, sorry, didn't spell that very well. That's the topic that we're going to be discussing today. And what we're going to do is we're going to learn how to dilate this figure. And I actually have this down below, down here on a resource page that if I can actually get to it, and I'm going to show you exactly how we're going to do this. And so what we're going to do to start is we are going to dilate this by a factor of 2. And so our first work is to take this and dilate it by a factor of 2. And what that means is I'm going to take this coordinate that we said is the point 3, 2. And if I have a dilation of 2, or a zoom factor, we might also call it, that means I'm going to take each of these coordinates and I'm going to multiply them each by 2. And so what I'm doing is I'm stretching the figure by a factor of 2. And so when I do that, my new coordinate after I've dilated it is going to be at the point 6, 4. And so what I'm going to do is I'm going to go back to my graph paper, and you can do the same thing on yours. And I'm going to go to the point 6, 4, and I'm going to put a dot right there. And I'm going to label this point as A prime. So that point right there is A prime. And then I'm going to continue to do all of this for all of the points all around my figure. So this was at the point -1, 2. And so I'm going to use the same enlargement or zoom factor or dilation for each of these points. And so I'm going to multiply this by 2 again and multiply this coordinate by 2. So that means my new point B prime, is going to be at the point -2, 4. And so when I plot that, -2, 4 on the graph, that's going to be at this point right here. So I'm going to label this as B prime. Then I'm going to continue my work down here for point C. And point C we said was at the point -2, 2. And so I'm going to also multiply each of those coordinates by 2. and in doing so, that's going to give me -4, -4. And so I'm going to plot that new point on here. So -4 would be located right around here. And so that's going to be labeled as C prime, as that's my transformed point. And so then lastly, my last thing that I need to do, just erase that, is transform or dilate this last point, point D, and point D is located at the point 1, -2. And I'm going to multiply each of these coordinates by 2. And then that's going to yield the new point at the point 2, -4, which then I can go to 2, -4, put a point roughly right around there, and label that as D prime. So, with that being said, all of the shapes that we are going to dilate or stretch or shrink are always going to be shrunk or dilated from the origin, or this point here is 0, 0. So what happens then is we're going to draw a straight line from our old point right here out to A prime, or the reason that I went from A to A prime right up here was because I'm shrinking or stretching it from the origin. So there should be a straight line going from the origin through point A to A prime. There should be a straight line that you could draw going through the origin through point B to B prime. But after you've dilated each of the points, what I'm going to do is I'm going to connect all of them with a straight line, and that's going to give me my new figure that has now been dilated by a factor of 2. Forgive me for not having the straightest of lines, but this new shape B, A prime, B prime, C prime, D prime, has been enlarged by a factor of 2. And you can see that all of the dimensions are twice that of the original figure. So what I'm going to ask that you do now is I'm going to ask that you dilate this thing by a factor of 3. So pause the video on your own notebook paper right now. Take the original figure, so we're looking at A, B, C, D, and I want you to enlarge that by a factor of 3 and see what kind of shape we have. Pause the video and then we will see what you come up with. Hopefully you got something that looks something like this. So this has been my dilated or enlarged factor of by a factor of 3. And so just recapping again, I took each of the coordinates and I multiplied them by whatever the zoom factor and the enlargement factor was, and that process is called dilating a figure. And so the last thing that this is going to bring us to is this discussion point right here. It says sometimes figures look the exact same and sometimes they look very different. So what characteristics make figures alike so that you can say that they are the same shape? How are figures that look the same but are different sizes related? So it says in this picture right here, 3 of the following images are similar, meaning that they are related through a sequence of transformations including a dilation, and 1 is an exception. Okay, so essentially what I'm going to do is I'm just going to highlight to you that within this first example here, letter A, one of these is the exception to the rest of them, and the other one is not part of it. And so as I were to look through each of these figures, a lot of them look the same and some of them look different, and what we're trying to determine is which one does not belong, essentially. And so when I look at this picture right here, what I notice is that the letter D right here does not have the same kind of shape as any of A, B, or C. And so D has a different shape overall compared to the rest of those 3 shapes up above. And so I would say that is not similar. And then in this problem right here, letter C also does not have the exact same shape. It does not look the exact same way as the other ones do. And so the big idea that I wanted to get across today was looking at this, the last thing, the math notes, and this is something that I would recommend writing down. It's just worth highlighting in terms of what was accomplished in today's lesson. It said the transformation that we talked about in chapter 1 were called translations, rotations, and reflections, and those are rigid because they all maintain the size and shape of the original figure, meaning the original figure didn't change any shape or size. However, a dilation is something that transforms but maintains the actual shape of the figure. However, how we did that was by multiplying the lengths of a chosen factor. And so what we did is we had this point of dilation, and in our problem that we did, that was the origin. And what we did is we took a figure and we multiplied each of the vertices by whatever the enlargement or zoom factor was. And so remember, this is called the original figure, and this is the enlarged figure, or the image of it. And so we pronounce this A prime, B prime, and C prime. And so the last little bit to notice here is that while the dilation changes the size and the location of the original figure, it does not rotate or reflect the original. While the lengths can change, angles do not change under a dilation. The angle of angle A up here is the same as this angle right up here. These shapes are similar, meaning that they have the exact same shape, but their size is different. So hopefully that went well for you, and look forward to talking to all of you soon.